Our metals are on the left-hand side of the periodic table. So if we draw out our periodic table to be like this, we know that so hydrogen is a non-metal, and we have this step division, metals on this side, and non-metals here as well. And hopefully you can see that heavy line on your formula sheets, and you know then that the metals are...
Why is there a heavy line?
Oh, I didn't grab one single line.
The heavy line down here,
Yeah.
that is where the lanthanide and actinide series actually join in. So that bit down the bottom. And if you look at the numbering, you can see that the numbers fit in there. Yeah. So they're all metals as well, because they're all on the left-hand side of the heavy line, that division between metals and non-metals. Alrighty, must be time for some questions. I'll finish those questions later. Now on page 13, in our top table, we have the common properties of metals. So these are properties for all metals. That metallic luster that we were just talking about. And you can see here that the description for it is mirror-like shininess. What do you think mirrors are made of? There's a couple of mirrors in the display cabinet out here, and you've probably got a mirror or three at home. What's it made of? Animal, vegetable, or mineral? What do we think? We look at them, well, some people look at them more often than others, but they're designed for looking at, aren't they? When, you know, like sometimes a mirror breaks, what's that bit? What can you see when there's shards of a mirror?
Black on the other side.
Black. Okay, but I'm thinking about the
There's
front.
usually like glass, and then
Glass.
there's like a thin.
There's a thin bit at the back of the glass. So we've got glass on the front, that's common. Then there's this thin bit. What's it made of? Do we think it could be a metal? Because it looks real shiny. And we've decided that metals are shiny. Yeah? It's actually silver. And if we think about it, it makes sense because silver doesn't oxidize very rapidly anyway, and with that glass over the top, that's going to be also protecting the silver.
Isn't silver really expensive?
Well, if you only have a really thin coating on it, then it's relatively cheap, isn't it? You only need enough of the layer to reflect, because most of the thickness of a mirror is glass. Okay, so the mirror-like shininess makes sense there, doesn't it? Because our mirror's silver. Silver's a metal. Good conductor of heat. And the description here tells us that heat can easily travel from one end to the other. So maybe I don't know, if you've done some cooking, or maybe, you know, you're stirring a pot of soup, you might decide to stir the soup with a wooden spoon, because if you're stirring it with a metal spoon, it's going to get really hot, isn't it? And you're going to say, ow, you know, that's no good. Or even like a teaspoon, you might find that you know, if it's a hot drink, your teaspoon gets really hot, because metals are good conductors of heat. Also a good conductor of electricity. So if we attach electrodes to a sample of metal and we run a current through it, that's going to travel through that metallic object quite easily. And in fact, if I do have an object, just say it was like a teapot, okay, sort of like that. Just say I'm running a current through it. It's attached to a power supply there. These wires, what are the wires made of?
Copper.
Copper. And copper is a metal. Yep, so we're already using that good conductor property in our wires that allow us to test that it's a good, you know, that they're good conductors, and that's a property there. Okay, malleable. And if you read here, the description of malleable is that it's able to be beaten into another shape. That means if you hit it with a hammer, you can change its shape. It's not going to shatter like that glass did, or like our ionically bonded substances do. Okay? We can hit with a hammer. Make it change shape. And ductile. As it says in here, able to be drawn out into a wire. So you can do some stretching of it under certain conditions, like you have it warm so that it can be drawn out, but it can be drawn out into quite thin wire. Now, when it says all metals, these two are going to be really difficult for mercury, okay, because mercury is a liquid. So when we say all, we're sort of making a generalization that takes into account that some metals are going to be better at it than others. And gallium, which is my favourite metal, is also perhaps going to struggle a little bit with this one because it melts at body temperature. So it's the next one to melt after mercury. And so yes, we could hit it with a hammer, and we can. It's malleable, but just that action of banging it with a hammer will warm it up, and then it might melt. And then, yeah, and the same here. Trying to draw it out into a wire, it's going to be harder to do under normal conditions. Now, there are other properties that vary from metal to metal. Density is the first one. Okay, so that's for all metals, and then these are variable. Density. Do you all know what density is? What is it?
It's the amount of, is it atoms or like in an area?
Okay, atoms in an area is almost there, but not quite. Density, we normally use the symbol rho, or the Greek letter rho, is equal to mass on volume. And so some of our metals have a low density. For example, our group 1 metals, relatively light. And then we can think about some very dense metals like gold or lead. And the way we perceive density is they feel heavy to us if they are dense. So that because when we hold a small bit of it, they think, oh, that's heavy, because they're only taking up a small volume. Hardness is another one. It's resistance to being scratched. So again, our group 1 metals, some of them are very easily cut. Well, we think about iron and tungsten and some other harder metals. Then we know that they are quite hard. And that nail that you're all hanging on to, it's pretty hard, isn't it? The melting point, as we've already talked about, mercury is already a liquid at room temperature. There are only 2 liquids on the periodic table, mercury and bromine. And so mercury is the metal and bromine is the non-metal that are liquids under.
What's the freezing point of mercury?
That I don't know off the top of my head. Actually, its melting point is minus 39 degrees. So, at around about negative 40, so as cold as your freezer, you'd be able to make mercury solid. And tensile, and one that has a very high melting point would be aluminium. So just an example, the tensile strength. So if we put it under tension, so that means being able to pull it like in the cable, then that is variable for metals as well. So when we're talking about properties of metals, we'll generally stick to these ones that are common, but often we can also refer to this density, because if it is a dense metal like gold or iron or any of the heavier metals, this is because we've got the close packing of the cations. That's what's making it dense, and that the cations have a high mass. So if we think about our group 1 metals there at the top there that have quite a low mass, lithium, sodium have low density, they're only small, and so they haven't got much mass in their nucleus. They end up being less dense than water. So here we are classifying metals on what they can do, what they are good at. They're good at being malleable, ductile, conductors, and shiny. And we classify our non-metals in what they can't do. Right, so we need to be thinking about what our metals can do.